All right, multiplying polynomials. It's hard for me to deal with polynomials and not multiply them. But anyway, all right, so multiplying polynomials. What does that mean? Well, that means we've got two polynomials and we want to multiply them. So, for example, 2x plus 1 times, say, 4x minus 3. Whatever, doesn't matter. So, there's sort of three main techniques for organizing your work. There's the horizontal method, and this is what is shown most often in textbooks, I think, because horizontal makes it somewhat easy to typeset. Certainly in the books I've looked at, they've done this. And there's also, so there's a FOIL. We have the term FOIL, first, outer, inner, last. People seem to love that. I don't know why. But, so the first refers to multiply the two first terms. Outer is the two outer ones. Green is the two inner ones. And then blue here. And then the last are the last two. Right? So you multiply all those things together. So let's see, the black was 8x squared. The red was minus 6x. The green was plus 4x. And the blue is minus 3. And so all told, that's 8x squared minus 2x minus 3. Okay, so it's a little messy. You can miss terms. The idea, though, is if you've got these two binomials, you do 4 multiplications, and then you combine the common powers, right? And this will continue on with things with more powers. Let's say 2x to the 4th plus x cubed plus 2x times 7x plus 1. Right? Now you can't do the FOIL thing, first, outer, inner, last, but it's still like, you know, you take that term, multiply it with those two terms. You take this term, multiply it with these two terms. Take this term, multiply it with those two terms, right? So how many is that? Well, that's basically 6, right? 3 from the left and 2 from the right, so 3 times 2 is 6. So that's 6 terms you have to do. And so it's 2x to the 4th times 7x plus 2x to the 4th plus or times 1. And then green is x cubed times 7x. Oops. X there. Plus x cubed. And then the blue was 2x times 7x plus 2x. And then add them. Add them up. And you get your answer. Right, which here is, well, it's 2x to the 4th. Oh, sorry. 2 times 7 is 14. So that's x to the 5th. And then the x to the 4th terms, 2x to the 4th. So that's going to be x to the 4th. X cubed there's just one x cubed term, I guess. And then the x squareds. I guess we just have one of those and one of those. Well, whatever. So 14x to the 5th plus, so that's 2 and 14, 16x to the 4th. And then plus x cubed plus 14x squared plus 2x. Okay, so it's messy. It's really easy to make mistakes. But this is a distributive rule, right? As I said, that's probably the most common thing you'll see in a textbook. Now, I don't recommend that technique. There's another technique, which I still don't quite recommend, but I think it's okay. And that's basically doing the vertical multiplication. Just like when you're multiplying two numbers together, you write one above the other, and then you have these kind of sequences. It's the same idea, right? And so I would continue to do left to right, so 4x times 2x, so that's 8x squared, and then plus 4x, and then another row, minus 6x, and then minus 3, so minus 3, minus 2x, and 8x squared. Okay, that's pretty cool. You can do the same thing over here. So 2x to the 4th plus x cubed plus 2x times 7x plus 1. So left to right, 14x to the 5th plus 21x cubed. Sorry. I don't know where I got that. It's 7 times 1. 7. Oh wait, 7x to the 4th, right? And then plus 14x. And then 1 is just 2x to the 4th. Let's see, cubed squared 1 plus 14x squared. 7, sorry, 2x to the 4th plus x to the 4th, 14x, no, sorry, 2x to the 4th plus x cubed plus, there's the x squared, just not there, plus 2x. Plus, this is 14. Oh my goodness. Wait, what? No. What is that one? Oh, sorry. Looking at the wrong thing. That should have been 9. Okay, well, whatever. Things are still not free of errors. All right, now there's a third technique. So that's called the grid, or I like to think of it as a box. And the idea is, this is the fundamental notion of multiplying, is to multiply things to make areas, and so you've got 2x and 1, and then you've got 4x and minus 3. And now you just multiply each of the terms, 8x squared, 4x minus 12x minus 3. And then you just, did I write that as b squared? And now you just kind of go along the diagonals. So this is 8x squared, and then this is what am I doing? 6x. Minus 2x minus 3. Right? And that's your polynomial. All right. And then over on this side, you can have 2x to the 4th, x cubed, and 2x. Oh. So I would recommend having slots here, sort of for each power. I mean, I'd probably recommend it for all of the techniques, but I think it's particularly noticeable in this one. So 0x squared. 2x and 0. It's just sort of to keep the diagonals aligned. And then you've got 7x and 1. Right, so that's 0, 0, and that's 0, 0. That's fine. 14x squared and 2x. We've got 14x to the 4th, and we've got 2, oh, sorry. X to the 5th, 2x to the 4th, 7x, 7x to the 4th, and x cubed. Alrighty. And so now we look at the diagonals. 0, 0, 0, 0. Okay, this is non-trivial. And then there's that one. Right. Theoretically, I'd have more space somewhere. But we've got 14x to the 5th plus 9x to the 4th plus x cubed plus 14x squared plus 2x. Hopefully that corresponded to one of them. Okay, good. So that's sort of how to multiply polynomials. Why don't we go take a look at what happens in, like, graphically with these things when you're multiplying them. So let's say we got 2x plus 1, it'll be our f of x, and then 4x minus 3. So these two polynomials are just two lines, of course. Now when we multiply them, so that's just f of x times g of x. And there you go. So notice something. The two roots are just where the zeros are of those lines. That's extremely important. 2x plus 1 times 4x minus 3 is the factored form of the quadratic. And so they give you the roots. And of course, the vertex is halfway between those roots. It's a nice feature of parabolas. Okay, I don't know if, oh, what is that? Oh. Oh, that's nice. Jiminy Crickets. Or because it doesn't want to do those things. Anyway, so that's a picture of the one. What about the other one? So let's just there we go. Okay, so 2x to the fourth plus x cubed. Cubed. So you always, when you write exponents, for some reason, these boxes, they like to put you in the exponent. To get out of the exponent, hit an arrow key to the right. Seems to be a quite common convention. Probably helps somebody. All right, so here's our polynomials. So this is the fourth degree polynomial that I've written down here. Kind of a funky shape. Nothing much interesting as we zoom out. And then here's our line. Now when we multiply them together, we get a totally different looking kind of parabola. We've got a max up here, a min down here, and we have the same roots as f of x, this green polynomial, as well as the line, right? So we multiply two things. The zeros multiply and make you 0, and so they always, if you know the zeros are the two factors, then you know the zeros are the combined ones. It's just the same. And in between the zeros, you have to have either a max or a min because it has to turn around, or the 0 is a max or a min. That's pretty much just what has to happen. And so it forces the change in the shape here as well. Okay, so that's multiplying polynomials. Obviously, if you want to know that you multiplied it out correctly, you can just go to Wolfram Alpha and no doubt many other sites. People love to multiply out polynomials. And I'll multiply it out for you. I'll give you a graph, give you some alternate forms, expanded form, that's the one you probably care about. It's nice, it'll tell you the roots, all sorts of things. And 2x to the fourth plus x cubed plus 2x times 7x plus 1. And there you go. Alternate forms, expanded form, that's the one you probably want. Which seems to correspond to what I got. Let's see if they show me the step-by-step solution. Oh. Yeah, they want you to unlock the whole thing, but you can see most of it. They're doing the sort of this vertical method, standard multiplication. They've added in the zeros. Very good idea. And there you go. So if you're really into this stuff, maybe you want to take a look at that or some other site that will do these problems for you and give you solutions. Who knows? Alrighty. So I think that's multiplying. They're all multiplying polynomials. That's all the same thing. And it's a really crucial thing, particularly the factoring kind of stuff. You need to be able to understand that if you have these two factors, how to multiply them to get the whole polynomial. That's how you can verify that you factored it correctly. There's lots of problems I love to ask about factoring. Also, that's how you see the zeros. Factored form of a polynomial is in many ways a golden opportunity for understanding it. So take some time to really think about through this, and you can write down whatever combination of powers and coefficients and multiply them together. Lots of easy practice. Wolfram Alpha will tell you if you get it right. Easy peasy. Also, I suggest graphing it, each of them separately, and then the product, just to start getting a feeling for what multiplying polynomials is doing to these polynomials. It really changes the shape. And then you can contrast it with adding them, right? So if instead here I had plus, for example, you know, it doesn't really, it changes it, certainly. It's just, but, it, you know, a lot of it doesn't change, right? You're not changing the degree. The dominant power, this highest degree, is still going to dominate. So if I look at the graph of these two things far away, you can't even tell them apart, right? It's just near 0 where it matters. And there it's going to be, because the fourth degree polynomial didn't have a constant term, you'll actually see that the constant dominates the sum here. So you get some of those things, and you get a little bit of flavor like that. But for the most part, adding polynomials doesn't really change their nature that much. It's just, you know, slight adjustments. Multiplying changes their nature very much. It combines into one polynomial all the zeros of the other ones, makes some max and mins that weren't there before, changes the big behavior. So for example, when we did multiply these together, like so, you know, the green polynomial was going to positive infinity on either side, whereas this combined one goes to negative infinity and one goes to positive infinity, which you can think of as the contribution of the line, but whatever. If I had, well, it's about the odd powerness and stuff. So, you know, as you know, if you really want to get into this stuff, you need to explore it like this. Write down some polynomials, multiply them, add them, do it by hand, do it graphically, check it with Wolfram Alpha, and you'll be a master.